So I think that you all received already a link to this GitHub page, and if not, you may copy it from here. And we will start actually with some exercises which don't involve any programming at all. I'll just show you some maybe, let's say, alternative ways how you may extract data without needing any programming, any API access at all. So, there is this tasks folder, and here is step 1 task. And here I will show you how to extract some tabular data with Google Sheets. And Google Sheets also have some way to interact with the web, with the information you may find on the internet. And I'll show you a small example how you may extract a table from some web page. And let's say we want to, here is a link in this step 1 document on the demographics of the European Union Wikipedia page. So let's go there, and we see that there is a table of the population and total area of the 27 member states of the European Union. Let's say I want to get that for some reason, for some analysis, I don't know. And Google Sheets provide some convenient way to do that. So I want you to go to your Google Drive and to create a new Google Sheets document. So yeah, we have this demographics of the European Union webpage, and we want to get this table. So what I'm going to do, I am going to use the function which is called import HTML. So the syntax is as in Microsoft Excel, so you have this equal sign and then you write some formula. And the syntax for this formula is that you have URL from which one you want to scrape this data, get this table, and the URL is this nwikipedia.org, so I'll just copy it. And then I have query, and query can be one of two. It can be table or list, depending on what type of structure contains the desired data. So right now, this is a table. So in the query, I will put table. And the index is the index starting at 1, which identifies which table is defined in HTML source code, which should be returned. It may be a little bit tricky how to get that without going into HTML code. I just know that this one, this description thing, is considered a table, so it will be the first one. And the one we are interested in is the second one. So what we are going to do, we are going to go into our Google spreadsheet. I don't know, for some reason I can't make this bigger. I will try to do that when you will have a practical exercise. But yeah, the final formula would be equal sign import HTML. Here you have this URL. Then you're specifying that you need the table, and this is the second table. And if I insert it into my Google Sheets, here you receive this all nice table, which is exactly as it was here. So you have member state, here it is. Then you have population, here it is, and so on. So this is like nice small feature of Google Spreadsheets, how you may extract some tabular data from the web without using any programming, just using Google Sheets. And Microsoft Excel has similar functionality as well. I just don't remember the specific formula, but if you're interested, you may look for that. So, what I want you to do now. So, if you are not here yet, then go to this GitHub page, this web page, github.com, Isupova, BSSDH/2022. Find the tasks and step 1, tabular data harvesting with Google Sheets. And here is the description of what I just did. And your exercise for now would be to find the table with the list of the largest cities in the European Union. So it may be Wikipedia, it may not be Wikipedia, just any source on the internet, and construct a query to import it into a Google Sheet. So yeah, and feel free to ask questions for me or to our assistants. And yeah, once again, you can also find full documentation for this import HTML. Yeah, in this, here is a link, basically. So yeah, this is your exercise, and let's take 5-10 minutes for that. Probably if you copy and paste, maybe it won't work because the Google spreadsheets require the specific format of these, how they're called, not parentheses, but quotes. So you may, there should be double quotes, so if it's not working for you, try to maybe change them. But it seems that lots of you and I have different versions of Google spreadsheets for some reason. So if it's not working for you, try to replace commas with semicolons. I don't know why this formula is working differently for you and me, but let's try to do that if it's not working for you. Is anyone still working on this exercise? Okay, so this is this was like a super small example for the Google Sheets, how you may extract some data without writing any code. And later I'll show you a bit more interesting ways how to do that with Google Sheets, how to extract some information from the web. It was just for the beginning. And let's go to the Python. And first, those who were on Python workshops may maybe zone out for a little bit, because we will be going through the concepts that you need to like understand and write this Python code. So if you don't understand anything, if you have questions, ask them right away, because these are quite simple concepts that I will be showing, but they are super important. And those who had Python workshop probably already know them. Those who had ARG workshop, you probably know the concepts, but maybe it's written a little bit more different in Python. So if you are interested in following along, in my GitHub, it's a prerequisites document. All right, so let's quickly go through Python syntax, and I think that maybe we can have a break after that, maybe not. We'll see how fast will we go. So one of the most notable Python syntax difference from other programming language is the thing that is called indentation. So you can't write everything with brackets as you do, for example, in R. You need to have specific amounts of spaces in specific places in Python code. What does that mean? So this is an example of the correct Python code. So you have an if statement, you are comparing variable x with a variable y, and if variable x is bigger than y, then you print x is greater than y. And you see there that this print statement has some spaces after that, and if you don't have spaces, it won't work. So it will get you an indentation error. So you see that if I launch this one in Colab, then it gets me that x is greater than y. If I launch this one in Colab, it says me that there is an indentation error. So Python expected me to have some spaces there, but I didn't. So that's why it didn't work. And how much spaces should be there? So if you have this if statement, or you have a loop, or you have some other statement, and you have a block of code which is inside the other block of code, actually there is like Python will allow you to have any amount of spaces, but the standard convention is to use 4 spaces or a tab. So be careful with that. If your code is not running and it says that you have an indentation error, probably it has something to do with all this thing. And if you don't want to do these spaces, you can just write everything in one line, and it will also work just fine. But yeah, these spaces, super important in Python, may be super confusing if you are coming from other programming languages. Yeah, and comments in Python are started with this, there are many names, number sign, pound sign, hash sign, and yeah, this executes correctly. So if you want to put some comments in the code that are not executed by the program, you can use this number sign. And then we will need Python lists. And lists are a data type in Python. And lists are similar to arrays in other programming languages. And if we're talking about R, in R, the analog is vectors. So you have a list, as the number suggests, of different values which are somehow grouped together. So, for example, if you have a list on links on a web page, or you have a list of titles, and so on, you may put them into one structure, and in the code it looks like that you have square brackets, and separated by comma there are different values. And you can access the elements of the list. So if you print list 1 with the element 0, so lists start from the 0, not like in R where vectors start with 1. Yeah, be careful about that, because in R it would return an error, but in Python list starts from 0, and if you request the 0th element in the list, it will return you 1. Then what we will use Python dictionaries, and dictionary is similar to array, to the list, I'm sorry, but it's not just the values separated by comma, it's a key value pair. So, and keys also should be unique. So you have, for example, a dictionary, which is in curly brackets. You have key value pairs, so you have key name and value John, key age and value 30, key city and value Los Angeles. And you can also access the data in dictionaries in the similar way as you do in arrays, only instead of index, you use the key. And as you may see, it's quite similar to the JSON format that I showed you, in which I showed you this JSON response example, and it may look similar to the dictionary. So what we usually do in Python when we are working with these web responses or requests, we are using a dictionary, because it's essentially the same as the JSON data. Then we will need if-else clauses. Again, probably you should know about their existence, and just I wanted to return to how it looks in syntax. So you have different conditions. So you have equals, which is denoted by 2 equal signs. You have not equals, it's exclamation mark and equal sign, less than or equal to. So the same way if it's done in mathematics. And if statement is written like that. So you have if x is more than y, or equals, or whatever of these logical conditions I showed you, and you have semicolon, and after that you have this indented code block, very important, sometimes confusing, and you can do, if this condition is true, do whatever. For example, print x is greater than y. Besides of if, you have else statement. So if this is false, then this else block gets executed. So if x is not indeed greater than y, then you have this else statement. Again, else semicolon and this code block. Also there is else if statement. So if x, we check if x is greater than y. If it's not, then we're checking if x is equal to y. If it's not, then we are executing else block. So yeah, you may refer to that. You will need some if statements in the code we will be writing later. So yeah, also may be important to know how to write it in Python. And the last thing we will be using is a for loop. So I think all of you should know what loops are. So basically we are going through some values and doing things multiple times. And in Python, we can have for loops that iterate against, for example, the list. So we have a list of fruits, apple, banana, and cherry, and we're asking Python for every element in this array that we call x. We just print that. So this little snippet of code will result into this. So we iterate through every element of the list. We have apple, banana, and cherry, and we iterate them, and we get this result. So yeah, that's basically all Python concepts we will need today, and we will have some new ones, but we will deal with them in the progress. Again, if you are struggling with Python somehow, I'm here, and our assistants are also here. Feel free to ask. And I see that the question is there, right? So yeah, the first question was about whether you should use Google Colab. No, not necessarily. If you have IPython installation on your computer, feel free to use that. The second question was about uploading the exercises. So these exercises I was showing you, like with this Google spreadsheets, you don't need to upload them. You will need to upload only the last one, and I'll tell you where when the time comes. I can maybe elaborate on that. So with social media, it's trickier. I won't address that today because it's kind of out of the scope, but we can talk about that in a little bit. So generally, Instagram and Facebook and Twitter and all those social media, their terms of services don't allow you to do this web scraping at all. So if they will detect this type of activity, they will probably ban you quite quickly. The good thing is that there are APIs to do that, and APIs have rate limits, but it's possible. And on Twitter, for example, it's super easy. Twitter is a very open platform, and that's why if you see research about social media and people activity on social media, it will be about Twitter, only because Twitter is the open platform and it's easy to get data from here using their API. With Facebook and Instagram, as they belong to the one and the same company, their policy is similar, and it's quite strict. So for Instagram, I'm not sure what was it specifically, but I think you could only scrape these business pages. I'm not sure. You check that if you wish, but it's again very limited. For Facebook, I know for sure that you can monitor up to 100 pages, and that's it. You can't do more. And there are ways how to address that as well. There are different solutions called social media monitoring tools. Maybe you heard something about Brandwatch or Meltwater or something like that, which are companies that collect this data for you, and you can access that in their applications, but they're subject to Facebook, Instagram limitations as well, so they generally don't have much data, and if you want to monitor specific pages or something like that, again, you are very limited in what you want to monitor. So to answer your question, it is possible, but it's quite limited and quite hard. And I don't know any, at least, legal way around that, if this answers a question.
I have one more. At the point you mentioned that if you're working with small websites, small servers, you should limit amount of requests you're making, especially during working time. So about what numbers are you talking about? Like 10 requests, 100 requests, 1,000?
So generally what I do is I just introduce some kind of delay. So for example, 1 request in a second or something like that, or a couple of requests in a second. So I don't have specific numbers for that, but programmatically what Python, for example, will allow you to do is to send like 100 requests a second, and that can easily crash if you're like small, if it is a small website and it's on some private server, for example. But what people usually do, and I'll show a way how to do that, is to introduce some kind of delay. So we do request, we wait for a bit, we do another request, we wait for a bit, and so on. And it usually doesn't create any suspicious activity. So I don't have specific numbers, just yeah, usually you can see if you are bombarding a site with requests too much. So the delay times become quite long, and if you see that you are waiting for your response for quite a long time, that may be a sign that you are bombarding the website with requests. If this is fine, I'd suggest that we do a 10-minute break now before starting the other topic. And so I'll wait you back here at 10:50. Right now, it's time for step 2, data collection using API. And right now, I will be using an IPython notebook from tasks step 2. And I'll be writing some code as I go in the Google Colab. So if you haven't worked in that, you can go to the address colab.research.google.com, or just search on the Google Collaboratory, and you can create a new notebook here. So I will do that. And I'll write some code here. Either if you worked already in Python and you have IPython notebooks at your computer locally, you can do that. Or you can just copy what I'm doing from the GitHub. So yeah, when we get to the exercise, and if you will have any problems with launching that, either me or assistants will help you with that. But everything I will do in Google Collaboratory in the browser. So I won't need to install everything, and that you and I have the same environment. And probably if something won't work for me, it won't work for you, and vice versa. So yeah, if you want to do it somehow differently, please do that. And also we will be using Scrapy at some point, and actually it's even easier for you if you will be using local installation, because we will be working with folder structure. So yeah, feel free to use whatever you feel comfortable to use. And let's return back to our GitHub, step 2, data collection using API. And here we will take a look at different APIs. I will be showing some examples on the Spaceflight News API. And as we have news topic, I decided that why not? And it's also free. You don't need API keys to work with that, so you don't need any registration. So there will be a task connected to this Spaceflight News API. Then we will briefly touch upon Wikipedia API, but as I said, it's quite complicated to work with, so I won't be focusing on that. It's just, its documentation is quite messy, it's just quite hard to do that. Then we will work with GDELT API, which is this global database of events, languages, and tones, which collects news from different countries and different languages. And I'll show you briefly News API and Twitter API and all these sorts of different cool APIs that you may use further. So this is API request format I showed you in the presentation. So usually you have this endpoint, and then you have query string parameters, and we will try to utilize that writing our own API requests. And yeah, I also told you about that. If you forgot something, you can reiterate that in this IPython notebook, so you can have different formatted responses. So for example, in JSON or in XML. And here, let's take a look at Spaceflight News API. So very often for different APIs, there is a possibility to try it out and construct API queries in API Sandbox. And it is also for this Spaceflight News API. So this is a database that collects all news that are connected to spaceflight, as the name suggests. And they have a free API, and this is the documentation. So you have link in this document on GitHub, but it's api.spaceflightnewsapi.net, so you can find it. And here are different endpoints which you can query. So this api.spaceflightnews.net version 3 is like a base URL to which you connect different endpoints, and then you can query the database. So I'll show you some examples, probably it will be easier. So you can ask this API to return some articles. And how you do that? You, for example, have this endpoint articles. So in reality, you will have this address, https API /version3/articles. And here you can try it out. So I'll click this try out. And you see there are different query parameters like limit, sort, start, and so on. You can read what they mean later when you will have the exercise, but basically I will show you an example with this limit. So what I'm trying to do here, I'm trying to ask this API database to return me articles about space flight news, and I will utilize this limit query, so return me please 2 articles. And lower down there, there is a button execute, which executes this query. So you see that it formulated the query, which is this one. So as I said, you have this base URL, which is, no, I think you can see, up until there. So all API queries to this database, to this website will start with this query. Then you have articles endpoint. After the question mark, you have the query parameter, which is limit 2. So I'm asking it to return me 2 articles. And I get a response. And response is in a JSON format, as you see. And the structure is very similar to Python dictionary. And you see that it returns some different information. For example, ID of this article, you have title, and you have some images here, and you have a link for that, news site, and so on. Some summary. And this is basically what you get from this API. And the question is, how do we get it now in Python? So now I will go to my Python notebook, and for that I will need a standard Python library, which is called requests. And I will import that. And let this Colab notebook start. A couple of seconds. Okay, it works. So, and the requests library have a method called get. So remember this get request. So we want to ask the server to get us the information, to retrieve this information. And we are doing that by writing requests.get. And here we need to insert a URL. So I go back to this Spaceflight News API. I grab this request URL it generated for me. I'll just copy that. And I'll just put it there. Yes? Okay, so here is this API. I'll go through the process from the very beginning. So I have the Spaceflight News API documentation. So I know that I need to go to this website in order to retrieve some news information from here. Thank you. But all the links are also on this GitHub repository as well, and this Python notebooks. So does anyone have access to this link? I'm sorry, I can't probably enlarge it. So maybe I'll just go through these steps and then we just solve all the problems with collabs for everyone. I suggest we do that because, I just have one more thing to show, basically. So yeah, we have this request.get method. So we have a response. Let's create a variable response, and then we have called the method response.json, and we get basically the same what we got on this website. And now let's solve all the problems that I'll leave on the screen, this small code snippet. And yeah, let's get everyone to have access to this information. So let's say that we have an API, we know we want to query, and in this case I want to query this Spaceflight News API. So in order to do that, I go to the documentation, which I have. And I know that I want to extract some articles, so I go to the section article. And here you see that there are different ways to do that. So we can find article by its ID. We can find information about different space launches. We can find information about different events. But what I'm interested right now is just plainly getting articles. So I'm going to this section, and we already see that the URL we will be querying is beginning with this string on top, so this api.spaceflightnews.api.net, and then we attach to that this /articles. Actually, you don't need to do that because it will generate this API query for you automatically. What I just need to do, I need to click this button, try it out, and say that I want to limit results with 2, because otherwise it will return me a lot of articles, and I don't want to do that. And then I'll scroll to the end, and I press execute. And it formulates for me this request URL. This is URL which I need to input in order to achieve the result I want, so the 2 articles about the spaceflight. And I receive a response. So here is a response which I can then store, somehow analyze in Python, and so on. And to do that in Python, I can use a library called requests. I just copied that URL, and I can get a response JSON, and that's we did up until now. And if you are OK with this information, I have an exercise for you. So the exercise is read the documentation and find out how many articles are there in the Spaceflight News API database. So the answer is somewhere in the documentation. So you need to find a query that you need to execute in order to find out how many articles are about the topic. So can anyone tell me the number you got? Okay, is there anyone who gets other number than 13,000 something? Okay, for those online, I will quickly go through what I was asking for. So the exercise was find out how many articles are there in the Spaceflight News API database. And what I wanted to do to go to this documentation page, which describes all the API calls you may want to do. And actually there is a query in the articles section and articles count that returns to you the exact number of articles in that database. So what you need to do, you can click try it out, and you can click execute, and it will return to you this string and this response. So you don't even need Google Colab for that. You can just create a query in this playground, and you will receive an answer. So no Python for that, just playing out with the documentation. And if you want to get it in the Colab, you can copy this URL. So again, it's in the section article and articles count. And you get this API query, and I can copy that. And yeah, I can create a new section. So here is a new URL, which is spaceflightnewsapi.net/version3/articles/count. And then I can call, I can create a response variable and store that requests get URL, and then I can have response JSON. And here I receive this 13,768 articles. And while we, for example, may need an API to receive this count, let's say that you are monitoring whether there are new articles. So instead of getting all of them, you can, for example, run this query periodically. And if you see that number changes, you can go and fetch all these new articles that appeared during this time. And so this is a small example of this API, how you may use documentation and find necessary information here. So let's move forward. And let's move forward with the fact, okay, so we got this number here, but how do we, what do we do further with this data in Python? So you see what I did there? I just put all the requests here with all the parameters and stuff, but actually, usually we don't want to do that because, for example, if I want to change this limit, if I want to make my query not 2 articles, but 5 or 10 or something, I need to go and modify this URL, and that's usually not what we want to do in programming. And what we want to do in programming is to make this value somehow changeable, so we can go to this variable and change that. So for that, as I said, all this thing after question mark is called parameters. So we can create a variable which we will call parameters as it is. So here we have a parameter which is called underscore limit. Pay attention to this underscore, because without that and nothing will work. And it is a dictionary where we have limit key and value is 2, for example, here. And how we now call this URL, get this response, we again use this requests.get method. Now we don't put the parameters here, we put only the base URL, and we pass parameters as argument. So we have argument params, not parameters, params, and call parameters. We will go through that once again, and I'll just check whether it works, because I'm not sure. Okay, I don't need this one. Okay, this works. So you see that we received two articles. So what it does under the hood, so I'm passing this underscore limit parameter. I set it equal to 2. What I'm doing here, and what Python is doing under the hood, it is transforming it into this URL. And why am I doing this in Python? Why I want this dictionary object is because that if I want to change it, let's say to 5, I can do that by changing that. And you see that now we receive 1, 2, 3, 4. I can count 4. No, 4, 5 articles, yeah. And if you want 10, we can put 10. And this can be a variable that we may change as we wish. So usually there are 2 ways that you can call an API query in Python. You may call this whole string and it will work. But if you want to make it a little bit more changeable, if you want to have an opportunity to change it on the fly, to make it a variable, then you may use this object and call it as params to parameters. So maybe it's not super important to understand that, but maybe it will be useful for you later. So yeah, and right now, okay, so we got this 10 articles, but we want to store them, for example, as CSV. How do we do that? So there are many ways, of course, to do that. I will be using a library called Pandas, which is a library for working with data frames, which is essentially a table of data. And I will use it just to save my data as a table and then save it to CSV. So it will work like that. So I'm importing this Pandas library. In Colab, it is installed. If you are not working in Colab, maybe you won't have it. So we will solve this problem later. And then, I'm sorry, I don't remember the exact query, so I will copy it. And I will call a function. So I'm importing pandas. I'm calling, maybe it will be even easier like that. So yeah, I'm importing library pandas, and then I'm asking to transform my response to JSON and to store it into a data frame object. And you see that this data frame is essentially a table. that Pandas created for me. So there is ID, title, URL. I'm sorry, I made things bigger so you can't see everything. But essentially what it did, it created a table for you, which you can now save in any format you want. So you see I asked the API to return me 10 articles. And now let's check whether there are indeed 10 articles in this data frame. So it starts with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So here are indeed 10 articles. If you change this to 2, for example, and it returned me 2 articles, and then I asked Pandas to transform it to the data frame. Now you see that we have 2 records here. And now we can save it as a CSV file. And I won't lie to you, I'll just copy and paste it from me. So yeah, we can call a method. So yeah, you see we have this df data frame, and then we can call df to CSV. We can call this whatever name we want. And so here in Colab you have file storage. There is a button Files on the left. And there are all files you created, so there is sample data which was created automatically. And here you see that I saved this spaceflight news CSV. And if we open it, we see that there are 2 rows with the data from this API. So yeah, you will have opportunity to try it out. But basically what I'm trying to say with that there are many ways to how to save this data and response to the CSV. But the one I prefer is that you can just copy and paste this code snippet and put this response here in the JSON format, and it will do the magic for you. And now let's take a look at GDELT. So here is the official website for the GDELT project. And yeah, you can take a look around. You can take a look around what it does. You can download something there, all this 2.5 terabytes of data. But there is a cool unofficial API for GDELT, which is called gdelt.github.io. And I want you to go there right now. So you see that this is a web interface that allows you to query GDELT database and to receive these news articles in different languages from different countries. And the cool thing that it does, that I can, for example, search for fuel in English, and if I choose source country, maybe try to make it a bit bigger. So if I choose a source country, let's say as Latvia, it returns me articles about fuel in Latvia, although I used an English word. So it translated to me automatically, and under the hood it uses this entities that I mentioned. So GDELT database automatically extracts the information that these articles are about fuel. And of course there can be errors, but in general, it works quite well, and you can get the information for source countries from there. So yeah, this is an unofficial interface, gdelt.github.io, and you can put all sorts of queries here. So you can also use and/or clauses here. So I want to search for an articles that mention, for example, fuel and I don't know, autumn. I don't know whether it will return any information. It will. And yeah, I see that there indeed in the title there is something about heating season and autumn, and it will be very difficult for us in autumn. So this is basically what article says. And yeah, we can search for all countries, and you see that there are some news in Arabic, in Russian, in English, in German. So yeah, this database queries that for you automatically, and you can use this and/or search terms. So for example, if you want to search for articles which mention both fuel and autumn, you use this and. Let's return back to fuel. And yeah, so I want to search only in English, let's say, to limit it somehow, because unfortunately, GDelt API is quite limited right now. They're doing some updates and it will become greater and cooler. But right now you see that there is this result number slider and it can be maximum of 250, unfortunately, right now. But for our causes, it will be enough. And another option I want to pay your attention to, so there is this recent, 1 day. So right now I'm searching for the articles only for the last day. But if this field is empty, then I can find news in the date range I want. So this database contains news articles starting from the January 1st, 2017. And you can choose any date frame you want, but yeah, the problem is that it will return to you maximum of 250 articles. But I'll return to 1 day. And why I'm showing you this? It's not only because it's cool, but because it can generate automatically API queries for you as well. So let's say I want to search articles about fuel in English and return them to me in JSON format. And you see that it generated me something that returned me this in JSON format. And why is it good? It's good that I don't need to go to documentation to search how the hell should I formulate my URL to include all of that. I can just copy whatever this GDelt in a web interface generated for me. And if I pass this into the browser, you see that I receive the JSON of articles about fuel in English for the last day. And you see there's all sorts of information. So there is URL for this article. And if we click on that, it takes us to this news website. So you see there is indeed something about fuel market. And this interface generates this query automatically for you, and honestly, I didn't bother with trying to formulate it myself. And if you look closely, you see that there is a query, there is a source language, there is some mode, max records and stuff. But again, I don't care about how to write that. I can just copy and paste that from whatever GDelt interface generates for me. And what I also want to show you, there are some visualization options. You won't need it for your assignment, but maybe it will be useful for you in the future if you will try to find something in this GDel database. So this is like an article list that I'm retrieving. There can be an article gallery. So you have these pictures from the article with the title and date. So it may be useful if you're doing some kind of visualization, or if you're monitoring this continuously. You can have all of this almost in real time, which is cool. And so you can explore. Basically, GDelt also extracts images from the articles, and it also detects what is on these images. So actually, you can also search for images and their tags, because they're labeling them automatically. So I encourage you to look around this gdel.github.io web interface, because there are quite a lot of information regarding news in a lot of different languages. And returning to the assignment. So basically what I'm doing here. So I extracted, so here I was searching about heatwave, it doesn't matter much. So I extracted this query. I put query as heatwave and source lang eng. I extracted this from this URL. I didn't come up with that myself. And the mode is artlist, max records, format JSON, time span 1 day. But again, you can just copy and paste this URL. Everything will work just fine if you just query, like execute request get this URL. And then you have this response. And let's actually try it out. So this request about fuel, what will happen if I just copy it and paste in my Google Colab. So this is the URL. Again, you see, I just copied and pasted it, no magic here involved. Not very convenient when you can't see everything. Yes, and Then I have a response, which is URL dot, or not URL, but requests dot get this URL. And if we see how response look in JSON, so yeah, you see there are a lot of data. And then I can, again, utilize pandas to convert this response to the data frame. So what I will do, I will create a new variable df, and I call pandas and transform it to data frame, this response.json, and then I can save this data frame to CSV. And let's call it gdelt data.csv. And it should work. And if I refresh this files tab, you see that there is gdelt data CSV, and okay, it wasn't parsed quite correctly. Sorry for that. I'll figure it out later. Okay. Yeah, this is because you see the format in which gdelt returns data back is that there is a key articles, and it returns everything inside these articles. So in order to save this as CSV, I need to extract exactly what is in these articles. But again, you can copy and paste this from this step to IPython notebook. So, okay, it was quite a lot of information. And here is your exercise for now. And the exercise is construct a query for the gdelt database. So going to this website, gdelt.github.io, with the following parameters. Search for the articles mentioning both fuel and nuclear search terms published in Latvia, Estonia, and Lithuania in these dates, and save the results as CSV. That is your task. So let's go further. I'll show you the steps for those who are online. So basically what I did, and what was the question about, that you should have go to this gdelt.github.io and just put the correct search terms here. So I asked for fuel and nuclear. Let's put it there. So it's fuel and nuclear. And yeah, we see that we receive some news articles about that. Then we need to narrow down the filtering. We have articles published in Latvia, Estonia, and Lithuania. So source countries, let's choose Latvia, Estonia, and Lithuania. Okay, maybe it doesn't return anything. I think it automatically adds this, yeah. I'm just doing that out of, because I'm used to. But I think it's if you just type fuel nuclear, it's just adds this and automatically. So you can do that as well, yeah. Oh, I haven't put everything yet. So then we have data range from 1st of June to the 30th of June. And to do that, this is the part where was the most problems. So in order to be able to change this date range, you need to erase this recent. And now gdelt allows you to change the date range. So we want to put 30th of June 2022 till 30th of June 2022. And we see that we get some articles. I don't know Estonian or Lithuanian, so I'll just assume that these are correct. No, in Latvian it is correct. So yeah, basically the steps that you needed to do, put here search terms, fuel and nuclear. Select source countries, Latvia, Estonia, and Lithuania. And the trickiest part would be to change the date range, and this web interface allows you to do that if the recent field is empty. And then the other tricky part was that I wanted you to receive the data in JSON format, for example. Then you need to select format JSON here. And you see that you receive this data in JSON format. And it generated the query automatically for you. So we can just copy that. We can go back to our Google Colab. Maybe I'll just do it once again. So we have this URL, which it generated for us. And if we take a look at parameters, we see that it puts here format JSON, start time, formatted in the format GDELT wanted it to be formatted. And yeah, there are source countries. And we did all of that without going to the documentation and trying to figure out in which format GDELT wants it to be formatted. And then we can get the response, which would be requests.get, and we put their URL. Then we need to translate this response to the format which Python will understand. Let's call this variable response JSON, and we have response.json. And now I want to transform into pandas data frame, which I do like that. And if I print this data frame, I actually see that something is not quite right. And why it is so? It's because of the format that GDELT returns the data. So you see this is the query I executed. And you see that there is this main articles node in which all the data is contained. So actually what you need to do, you need to ask Python to select from this response JSON only articles. And then it will be executed correctly and everything will look nice. So basically it's just the format in which GDELT data is formatted. So if you will be doing it once again and querying GDELT, if you will use this articles in square brackets, everything will work. And then I can just save this data frame to CSV, and let's call it nuclear fuel articles.csv, and we see that it's got saved here. So actually I have all these solutions written out, so maybe I can share it afterwards with Anda and she can share it with you. So if you want to reiterate it after the workshop, maybe it would be easier for you. So let's move forward. And regarding API, I have something else that I want to tell you. So there are other ways to access GDELT. And as I said, you can even download the data, but it's huge. It's 2.5 terabytes. You can't put it all in the memory of your laptop, unfortunately. There is a service which is called Google BigQuery, which you can interact with this GDELT database with. And it has all news, entities, and stuff. The problem is, and the reason why I'm not showing this to you, it's that it is expensive. So if I want to select articles about, let's say, nuclear fuel, and I want to extract people, which were mentioned in these articles, and then I want to cross-check whether these people were mentioned somewhere else, you can easily end up spending a lot of money. So anecdotal evidence, once at work we accidentally spent 200 euros a day querying Google BigQuery, which was not very pleasant. But yeah, this service exists, and yeah, if you have an opportunity, you can try this Google BigQuery out. And yeah, there is News API, which is another API for news, and I also won't be showing you that because it's like there is a trial version, you can register and see yourself, but I won't be showing that again because it's paid, and yeah, I unfortunately couldn't create a trial accounts for all of you, but yeah, it's called newsapi.ai, and the related project is called Event Registry, which is basically the same owners, and in Event Registry you have access I'll show you maybe after lunch break how it works, because I don't remember my account. But yeah, so this is one other news API you may consider if you want to query news. But yeah, it's paid, but not that painfully paid as this Google BigQuery. And where is it? Here it is. So at the beginning, there is also an API list. So there is list of news media APIs, which is collected on Wikipedia, and you may also take a look here. So there are collected mostly American websites news APIs, which you can use in your projects. So if you're interested in learning more, you can take a look here. And there is also a GitHub repository, which is called a collective list of free APIs. You can also look here, and you see there is a long list of different APIs about animals, about anime, about books, about cryptocurrency. I think there were news as well. So you see that you can find all sorts of API here. Some of them require authentication by API key, but I think, yeah, they should be all free. So yeah, you have like APIs with daily cat facts, random dog facts, whatever. So you see there are a lot of APIs. So yeah, it's in GitHub repository in this step 2. It's loading. So yeah, here is a collective list of free APIs. So if you're interested in querying something else, you can check this out. I don't know why it doesn't work. And right now, let's go to the most interesting part, which is crawling the web with Scrapy and web crawlers. So this is the basic HTML document structure that I showed to you. And usually what we want from web scrapers, we want to extract, for example, something from this title, something from heading, something from paragraph. It would be very easy if web was structured like that, but in reality, it isn't quite like that. In reality, HTML tags look something like that. So you have tags. This is A. A stands for link. And this is a link for contact us. So you see the content is contact us. And all the other is included in this, how is it called? So in this tag symbol. So basically you have element name, it's A, or it's H2, or P, or title. So that's the name. And then you may have different attributes. So the attribute you see probably most often is the class attribute. And this class attribute may have different name. I'll show you the example in a while later, but usually we are interested in classes. Why? Because the class is usually used for styling. So to make your web page look nice, programmers assign different classes for different elements, and then they can style these elements in some specific way. So very often elements have a class name, and you can find them by class. Often they have also ID, but with ID you should be quite how should I say, careful, because IDs are often dynamically generated, and if you are searching for a specific element and then you reload the page, ID may change. So usually we are searching for the class. And in this like step 3 lecture, we will be looking at the website which is called ENG-LSM-LV, which is Latvian news site English version. And it looks like this. So it's a news website, nothing very specific. It loads nicely. And OK, so for example, I want to extract this title. What should I do? And here is this magic tool, which is called inspect. So I'm clicking with right click and select inspect. It should work in any browser, hopefully. My browser is Firefox. I need to understand how to make it bigger. I know that I can somehow. 1 second.
Try Control and just scroll the mouse.
Oh, okay. I haven't expected that it will work for that. All right, so what we see here, we see the HTML code of this page. So we see that we have HTML element where everything is included. HTML have different classes, the lang attribute. Then we have head, which also have a bunch of tags here. And here is different like body and stuff. You don't need to understand the structure of this page because there is a cool instrument. So in my browser, you see there is like this on top left corner, this big element from the page button. So all browsers should have something like that. Please find it. And what you can do, you can click and I select with my mouse an element I want to like inspect, and it automatically finds it for me in the HTML code. So, for example, I want this article, and probably I'm interested in this like whole thumbnail. Well, not necessarily even. Okay, let's select only this title, and if I click to that, you see that it takes me to the point in the in this HTML layout where it is. So you see this is a tag. There is the class called thumbnail caption, which is interesting for us because we may use it later. There is attribute href, which is actually a link for this article. And you see that inside there is a content, more military aid to Ukraine approved by Latvian government. So if you go back, we see that the structure is basically the same. So there is a tag, which has a name A. We have class, and here this class is thumbnail caption. Then we have attribute href, where is a link, and we have this title, which is content. And then we have a closing tag. So what we may realize that, okay, now we need to find all A elements with the class of thumbnail caption on this page if I want to get all titles. But first we need to check whether it's true. So I can select again this element. I check the other one. So I see the structure is actually the same. There's again a tag. There's a class thumbnail caption. Whew, I'm sorry, I selected something different. So there is href, and there is the title. So all of them are basically the same. Okay, so now I know which elements I'm interested in. How do I get that in Python? All right, before we get into Python, maybe there is an exercise. So I want you to go on this eng.lsm.lv website and just think about what elements would be interesting for you to scrape to collect data about. So one of them is title, and we found out where title lives in. So I think I even wrote it down. Yeah, that each title for each article is in the A tag with the class thumbnail caption. The URL itself also here in the href attribute. So I want you to play around with this inspect tool to take a look at different elements, what you may be interested to query. Maybe you want to find a date. Maybe you are interested in this, I don't know, category tag. Or just look around what useful you can find on this website, what would be interesting for you to query. Maybe you can even open an article itself and take a look on the elements at the article itself. So basically, play around with the inspect tool, take a look what is there, and ideally you can even write down in a format like that the title is in the A tag with the class this and that, and have fun with that. There were some interesting questions arise that I can show to you as well. So first of all, let's see the main page. What could be interesting for us here? For example, we want to extract these tags, like defense here. What we do, we again run this inspect element, we select this defense, and we see that it's somewhere in thumbnail category, which is good. But the problem is that if you look closely, not all of these articles have this category. Yeah, for example, here is none, here is none. And if you start scraping it independently from each other, you may run into a problem. So usually what you want to do, you want to look for bigger elements which enclose all the information you need. What I'm trying to say with that is that, okay, I want to scrape all this information together. So we have this title, we have this tag, we have the date. How do I understand that they come from all in the same article? So if you play around with inspector, we may found the class that everything is kinda enclosed into. So the tag is article, the class is thumbnail. And what you can do, you don't necessarily need an element, a specific element, if you want to scrape it. You need to understand its address, and address could be, you know, you have like a street and you have a house, and here you have an apartment. Basically, that's the same. So you have a tag article with a class thumbnail. Inside here is an image. Inside here is details and also a caption. And you can kind of wrap all of that together. So in this example, we would probably be interested in this category. We would probably be interested in caption. We maybe would be also interested in date. And the date lives here, time. So basically, like I'm taking mental notes for myself. If I want to do this scraping, I need to go find all thumbnails, all like article tag with class thumbnail, and I need to go inside and see which information I can get from here. And yeah, we'll put all of that into practice after lunch. Don't worry, we'll get there. And yeah, also one question I was asked. So for example, let's go inside the article and we see that, okay, we may be interested in title, which is in H1 class with the class article title. Then there is article body, and there is also an interesting element that there are like tags in the end. And if you take a look at one specific tag, you see that it actually doesn't have any class. But all tags are like bound together in this UL, unordered list tag, and this element actually have a class. It's a class tags. And again, if you think about it kind of like a street where you have houses, where you have apartments, you can go to the street, which is called tags, and then inside you can scrape all the articles, not articles, but tags you need. So yeah, basically that is the hardest part of this web scraping, to find the correct address of the elements you want to scrape. So you need to understand, okay, if I want to get that this article is about Artis Pabriks, Defense Ministry and war in Ukraine, I need to go to tags and select all A elements from here. If I want to get a title, I need to go to H1 tag and to class article title and so on. So basically it's the hardest part of that all. And we'll see how to put it into practice after lunch, I guess, because it's time. And before we even start scraping LSM website, I saw that some of you were already checking. It would be a good idea to check the robots.txt file on nglsm.lv. And yeah, it's just /robots.txt, and what we can see that they allow everyone to crawl everywhere, which is good for us, and we can feel good from the ethics point of view. That's good. So now let's return to the article. Let's try to scrape one of the articles because you don't have like these nested data structures. So let's choose any one you like. I will choose this one, MedExpert test over pay in Riga, and I want to get from there this title. Then I want to get this lead section of the article, and maybe I want to get also the text of the article. Let's see whether we can do that. And for that, let's copy this link. We'll go back to the Colab, and before we start writing crawlers, let's try to extract all this information kind of manually, just to collect all these building blocks together. So for that, you need to install Scrapy first, and you can do that by !pip install Scrapy. And if you are on local installation, then you can use terminal to do that. Then you don't need the !, you just run pip install Scrapy and you're good to go. And yeah, I have it already installed, so it says to me that requirements are already satisfied. So when Scrapy is installed, we can import a thing from Scrapy, which is called from scrapy.http import text response. So as we found out, we receive from API's response. But when we send a GET request to the website, we also get some kind of response. It's just not formatted like nicely as a JSON file. It's just a bunch of HTML files and stuff like that. But it's still a response. If it's a response, then we can get some information from that, right? Right. So to do that, we import from Scrapy HTTP this text response. These code snippets are, again, on GitHub. You can just copy and paste that. And as a result, I just run requests get and this article about medics protests in Riga. And then I just run this text response object from Scrapy. So okay, you don't need to understand the details, what's happening there. Basically what this code snippet does, it transforms the response from the website into a textual information that you can analyze and extract some data from that. So let's run that and see what happens. So we got the very messy HTML file, and it's quite hard to get anything from there. But yeah, as we already analyzed this page, we kind of already know where we should look. And let's grab this response. And here we will use the thing that is called CSS selector. So as I mentioned, these websites are using CSS to be styled, to create these beautiful visuals, not just plain HTML. And for CSS, you usually use classes. So as if I want to extract this title, I see that it's in h1 tag in class article title. So I need to use a thing that is called CSS selector to select this element. And okay, it will be probably easier if I show you how to do that. So yeah, it's h1 tag class article title. So we go back to title, we have this response, and we have this CSS function, which stands for CSS selector. And here we start selecting this element. So I know it's h1 tag. It's just plain h1. And class you denote with a dot. So I know that this is a class of article title. And I don't know whether you can see on the screen, it actually highlights me h1.article title. So that means that it is h1 tag with a class article title. So I type it exactly like it was here. And you see that, yeah, there is indeed some data, although it's also contain all these tags and whatnot, which is not very convenient for us. So then we run a function which is called get, which extracts the information inside of that. Okay, we see that we are a little bit closer to the result that we want. We just need to extract this text from here. And that we do by adding to this CSS selector text. And yay, we got our title. So basically what's happening there? You can just copy and paste these things and insert the information you need here, because Scrapy is a framework. So it basically provides you a template to do things. And this is one of the templates that you can use. You can just copy and paste that and insert here your information, and the code will run and everything will be fine. So let's try to see how to extract, for example, this lead text. So we run our CSS selector, not selector, but inspect tool. We see that it's in h2 tag in class article lead. And again, if you see this highlight on top, it's h2.article lead. So let's try that. Article lead. And it works. So yeah, I'm saying to extract from all these mess, find the h2 tag with a class article lead and extract text from here. And it works. Then we may want to extract a text, and we see that the text of the article is in the div with a class article body, and notice that there are 2 underscores. And let's try that. Div article body. Okay, it's not very nice. Okay, yeah, you can't use really text here because there are, you see, if you look closely, there are a lot of paragraphs inside. But I'll tell you a little bit later what to do with that. For now, I'll just extract this as an HTML code and just leave it there. So what we did, we retrieved this page about with the article. We asked to Scrapy to find h1 tag with this class and get text from there. H2 tag with this article lead and get text, and the text of the article itself, which is quite messy for now, but that's fine, we'll deal with it later. So now when we have all these building blocks, now we can create this software, which this web crawler, which will extract this information for us. We just need to give a correct URL to that. So essentially, if we give to this scraper not only this URL, but all of the other articles, it should be able to do its work, extract this title, extract lead, article lead, and stuff. So how it looks like. I think it will become more clear and fall into places where it needs to be when you will do your practical task, but I'm just demonstrating step by step what should happen. So to initialize this crawler, you need to run the command with the exclamation mark, which is Scrapy. I don't remember, sorry. Start project. And let's call it LSM Spider. And what it does, you see that it says to me that new Scrapy project LSM Spider was created in the content LSM Spider. And if we take a look at the structure, you see that it created a bunch of files for us. And the one that we are interested in is in the folder spiders. So here we should create our spider, so our program, our software, which will do this all crawling and extract the data for us. And as I said, the main advantage of Scrapy is that it creates you a template where you just put your code and everything runs. So this is the part which is not really convenient in the Colab, I'm sorry. But here in the spiders folder, you need to create a file, which you call somehow articles.py, articles.py. So the name doesn't really matter. It can be anything you want. And then when you open the file, so again, all this code is available here. You can just copy and paste it. So yeah, this is the most important part. Here we write our spider. And here, how you name things is actually important. So first you need to import spider. Oh, Scrapy, sorry. And yeah, I'll just probably copy and paste that, and I'll explain to you what happens here. So, okay, it's not really. Maybe let's just. So yeah, basically it's a file in this content LSM spiders folder, and what it does. So this is actually the scraper that you are running on your web page, and what is happening there. So you obligatory should have a class which is named by the name of your choosing, but it should be a class, and I called it article spider. It could be LSM spider, it could be whatever, just it has to be a unique name. And each spider should have a name. So I called my article, and the name should be unique in the project. And here you have start URLs. So these are URLs that you ask Scrapy to scrape. So it's plural, so it can be more than one. And but it should be obligatory named start URLs. So Scrapy knows that it goes into this file, it looks for the variable that is called start URLs, and it knows that it should send requests to this web page. And then there should be a function which is called parse. So def is a function in Python, and this function should be obligatory named parse. And here you define all these CSS selectors that we did previously. So here we did response CSS. We get this H1 article title text, and you see that this line is the same here. Then we had this lead text, which I called subtitle. You see that it's also here. And yeah, we also get article body. It's also here. And yeah, that's basically the parts which obligatory should be here. And just for things to be kind of, so you can see what you did, I asked it to print title is, subtitle is, article text is. I will just copy and paste that, and yeah, for maybe to make it easier, I'll delete the article text. I'll just leave title and subtitle. And the start URL, yeah, is an article from LSM. So I know it's messy, but it'll probably become more clear when you will get step-by-step writing your own scraper. So right now, I have this LSM spider folder. In that, I have spiders folder. In that, I have articles py, which is extracting title and subtitle. So everything is kind of ready. What should I do now? I should run this spider. Oh, why it works like that? One second. And how do I run it? I execute scrapy run spider article py. And yeah, you actually should be in this folder where you're running that. So as I'm right now in this content folder, so well, basically probably it would be, okay, so what will I do? I'll import OS module from the standard Python library, and there is a function OS change directory, and the articles py is contained into content LSM spider. It's again LSM spider. And articles, no, spiders. Will it work? Okay, it works. And now I'm in this folder. Again, all of this code is in the repository in GitHub. Now I can try to scrapy run spider article py. And we'll see what happens. File not found, okay, because it's articles py. So you see that it started running something. Oh, what is this? So you get a lot of information here, but actually which is the information that you are most interested in? Okay, I don't know what happened with the layout. I'll try to maybe reload that. Okay, I'm sorry, I'm stuck a little bit with the layout of Google Colab. Okay, so we ran the spider that you wrote here, and we should get the title printed and the subtitle printed. And you see that indeed, title is resident proposed catalytic converter processing plant. Okay, it's the other article, and subtitle is, and you see that here it is. And what you can do, you can add more articles to scrape. So in the start URL, we had only one, but we can add more. And here we can go, for example, to the LSM website. And as all of these articles have the similar structure, probably it should work. Let's check that. Let's maybe select some other article. Construction costs continue to rise, let's say. Oops. So here we have 3 links, and what we expect that this spider will return to us 3 titles and 3 subtitles. Let's see what happens when we run that. Oops. Again, so it's scrapey, run spider, articles py. And you see that it scrolled, you see, 1 article, and it returned that construction costs continue to rise. And this lead text, then title is Medics Protest Over Pay in Riga, and then Residents Protest Proposed. Yeah. So you see that we got the titles of all 3 articles and subtitles of all 3 articles. So that's good, that's actually what we wanted. So right now, what I want you to do is basically to redo all this process, but for some Wikipedia article. So first you should, so there is step-by-step process. First you should check robots.txt file on Wikipedia, and maybe you'll just say that it's not allowed to scrape Wikipedia. We won't do this exercise, that also will be fine. Then you need to select 1 or 2 or 3 articles that you want to scrape. So for example, this was a random article, and you need to understand where the title is, or maybe some other information. So I'm asking only for the title, but if you will be able to extract something else, that's fine, that's also good. And yeah, so try to recreate this process, starting with scrapey start project, then identifying where title is, and then running this spider. I know that may sound like a lot, but I think that when you will start doing, and we will help you, this all will start going into place. And yeah, I think, do you have any questions, and do the audience online have any questions? But I'll just suggest starting doing that, and then, yeah, we will understand. You can, yeah. Not yet, but we'll see what will, will we have enough time to go further? So yeah, I suggest you to open this project on GitHub and just following step by step what I did with the previous one. So the steps are super similar, actually. So at the end of this lecture, you will need to submit something, and I suggest that you submit the Python script that you created for scraping the article. So in my case, this is article py. You can save it as a file and just submit. And where to submit, I will tell you later. But yeah, so just so you know, this will be something that will be required to submit. And now we'll see how everyone will get with their tasks, and maybe we continue a little bit further. So we still have some time, but maybe I'll just show you what else is in this document. We won't be able to go together much further, but if you are interested to learn more, feel welcome to take a look at this document further, and I'll just tell you what you may learn from there, and yeah, so what we didn't manage to do today, unfortunately. So basically, the result we got was just logs, so you should look for title and subtitle somewhere in a lot of other text, which is not very convenient. And what you want in the end is to save it, for example, as a CSV file, so you can analyze it further. And here in this document are the steps how you may do that. So basically you need to create a separate file called items. You should define a structure. So my structure was that there is title, subtitle, and article text. And then I could tell the spider how to do that. Again, don't think about it much now, but if you want to learn more about that, then you can do that as well. The other thing is following links. So the whole point of spiders is not to just crawl a couple of predefined pages, is to be able to traverse a website. So you see that in this code snippet, I defined that I want to scrape pages on the main LSM web page, and this code snippet extracted them automatically and went there and extracted title and the article text and so on. So that's actually the main point of scrapers. What they should be able to do is to follow links automatically. Again, if you wish, you can take a look at that. And yeah, as I mentioned, it's usually good practice to introduce some delay. So for example, 3 seconds, and you can do that by modifying settings py file in this scrapey folder. Again, can take a look at it later. And actually what I want to show you right now is that, okay, you see that it's not very easy to create all these scrapers, but you want to scrape this news anyway. What should you do? How can you do that? So there are services that can handle the scraping of the web pages for you. And one of them is called Zeit. And Zeit can actually do a lot of things. So it can scrape websites for you automatically using some AI magic. And it also can host your spider. So we have a lot of these scrapey spiders that you wrote. You can also host them on Zeit. And now I will try to log in. I think I had something left on my trial. So here is this automatic extraction. And yeah, so let's say that you want to scrape Delphi.e, so Estonian news site. So you see that there are articles. So if you wanted to create your own spider, you would go and look what these titles are, where they are contained. You would extract links. You should follow. You could follow links and so on. But this Zeit service can actually do that automatically, leveraging AI. So let's see what happens if we ask Zeit to extract news from this Delphi.e, and basically this algorithm, it knows that the title would probably be somewhere in the H1 tag, which will be called probably this and that, and yeah, so they are trying to approximate where these news will be, in what classes there will be, and they do that extraction for you automatically, which at least for me looks a little bit like magic, to be honest. So let's wait a little bit and see what will happen. So basically, when you are asking to retrieve a page, it is a request. So then on this page, you can do whatever you want, because you already got this page. But the request is basically when you are sending a link and you are requesting to get a result from this link. So yeah, if I'm going on this Wikipedia page of whatever it is, CBS Sports, so this was a single request to this web page. That's all. The main danger with this request is that if you, for example, have a list of 1,000 links and you are requesting all of them at the same time, that can create some problems on the server and so on. Okay, this Zeit extraction takes a little bit more time than I want. So actually I did already, no, it wasn't finished. Oh, it did something. Okay, so what this magic service does is that it extracted all sorts of articles from Delphi.e that extracted the URL, that extracted the headline, the author, the main image, and you see that it managed to do that for the 94% of articles it found on the main page. And you also see that there is some probability rating. So as I said, it's using the AI actually to extract that. So yeah, it's not entirely sure that they extracted everything correctly, but for 97% it's sure that yes, it is indeed the article. So There are these services out there, so if you don't want to write your own scrapers, or you need to scrape some data only once, yeah, you can use service, for example, Zeit, and there are actually quite a lot of them. But yeah, I wanted just to demonstrate how it works. And yeah, you may continue working on your task. And yeah, remember to submit it to this makonis.lnb.lv, and I will submit the solutions for these exercises in this GitHub repository as well. Yeah, it's time actually to finish. So I will be still here until the beginning of the next lecture. So if you wish, you may ask me questions. But yeah, for this lecture, it's basically it. Don't forget to make your submissions. And yeah, thank you.